we are looking at lesson 104, complex rational decimal numbers. They want us to review what a complex number is, rational decimal numbers. This should be review. You should remember this part from previous lessons. Standard form of a complex number, a plus bi. Y'all remember that? Okay. All real numbers can be written as a complex number. 4 is the same thing as 4 plus 0i. Y'all remember that? All imaginary numbers, negative 2i, can be written as a complex number. 0 minus 2i. That should be reviewed. Do y'all remember that information? Yes? All right. So, subsets of your real numbers. I don't think so. Counting numbers. 1, 2, 3, 4, your natural numbers. That's your smallest set. Do you remember what comes next? The next larger set? Whole numbers. What are whole numbers? 0, 1, 2, 3, 4, etc. When you count, do you include 0? No, but it is a whole number. What would be the next set of numbers? Integers, which include what? Negatives and the whole. So negative numbers, 0, and all positive numbers. What comes next? Rational. Numbers that can be written as fractions. You also have your irrational numbers. Numbers that are non-repeating decimals and that they do not terminate. What would be an example of an irrational number? No? That's a rational number. Because it's a fraction. Square root of 2, does it repeat? Yes. Square root of 2, does it repeat?
Yes, that's right.
I get 1, 4, 1, 4, 2, 1, 3, 5, 6, 2. So it doesn't repeat, so it's irrational. Anything that can be written as a fraction, is that rational or irrational? Rational. So 22 over 7 is rational. I know it is close to pi, but it is actually rational. Okay, so you've got your counting numbers in a box, and then outside of that box are your whole numbers. Outside of that box are your integers, Do what? Yeah. I was going to do it like that, but then I don't know how to write. Okay, I'll do it this way. I was trying to figure out how to make it so I could write irrational, like out, but I had made it too small. And then you have your reals. Yeah. Over there. Yep. They are separate from the reals. Yeah, I didn't draw it very well. You can. You don't have to. And then all of these are your complex numbers. Because technically any of these can be written as a complex number. Does that make sense? Yeah, like all of that would include your imaginary, reals, everything make up your complex numbers. So anyway, y'all remember doing that?
Complex.
Yeah, complex is all of those. The reals and the imaginaries put together. That's how you get a complex number. Okay, so we are going to take this decimal and write it as a fraction. Maybe. Not for all of them. Yeah, I told you. Not for all of them. Emily wanted to try and use her calculator and use that fraction thing, but it just didn't do it. So, that's my number. That's a fraction, right? But we still have a decimal in our fraction. So how do we get rid of a decimal? 10 to the what? 1, 2, 3, 4, 5. Why 5? Right. And so what do I do on the denominator? So what am I going to get in my numerator? 314 over what? Yeah, but you write it as 10 like that. Yeah, you don't want to leave it as 10 to the 5th.
So is it ever going to be like a big number or just like 10 to like 10?
Maybe if it is, you just always write it out. So it says we could reduce this fraction to lowest terms, right? But this reduction is not required because any fraction of integers satisfies the requirement. Does that make sense? It just says write it as a fraction of integers. Normally, you are supposed to reduce your fractions. But on these, you don't have to because it just wanted it as integers instead of a decimal. I don't think it does. Yeah, no. Well, you would divide by 2. 314 divided by 2. 157 over that divided by 2, 50,000. 157 is prom. So that's as far as it would reduce. I would take either one of those. Does that make sense? Either one work. I think the answer book is always going to give you this one though. Any questions? Okay, let's look at another one. Yes. 1, 2, 3, 4, 5. I know.
We'll always do fractions.
Yeah, you always want to write it as a fraction of integers. How can you check your answer on these?
Plug it back into a calculator.
Yep. Yes. 1, 2, 3, 4, 5, 6, 2, 3. I got it as a fraction. Am I done? Why not? 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8. Do you agree? So what do you get in your numerator?
So you always write the one and however many zeros.
Yep. Any questions? Okay. That one's a little bit different. 1.0031543, right? Keeps going on and on and on and on. It is rational because it repeats. And we want to show it is rational by writing it as a quotient of integers. What's a quotient? Quotient of integers, basically a fraction. You got two integers that you're dividing. So you're going to do these in a different way than you did the last one. Okay, leave a line on your notes and then write your number is 1.003153. We're going to put something above the number. How many times does it, or like how many decimal places does it repeat? 5, 4, and 3 repeat, right? They repeat over and over again, those 3 decimal places. So we are going to multiply our number by 1,000. Where did I get 1,000? 3 zeros for 1 for each decimal that repeats. Does that make sense? 5, 4, 3 repeat, so we're going to multiply by 3 zeros. 1, 0, 0, 0. Yeah, however many zeros you have, how many decimal places repeat. So if it was 0.33333, how many decimal places repeat? 1. Just the 3, right? So you would multiply it by what? By 10. Okay. So when we multiply this number by 1,000, where is our new decimal place going to be? Here. So it's going to be 1003 point what? 1543, and then what? 543, 543. Keeps going, right? Okay. We're going to subtract them. 1,000 n minus n is what? $999. Let's start over here. What numbers get subtracted? Yeah, so what is all of this over here? All of that goes away. You see how that works? Okay, what do you have left? 2, yeah. 1, 5, 1. Do you see how that works? It's no longer repeating, right?
I get the 50. This is not what I'm looking at.
I don't know.
Wait, can we plug this in our calculator? It didn't work.
I think it's just easier to do it in your head.
Yeah, something we did play.
Any other questions so far? How do you solve for your number? Can we leave it like that? There's a decimal, so what do we need to do? Why 10 to the 4th? 1, 2, 3, 4 decimal places that I needed to get rid of. So what happens to my denominator? I add 4 zeros. That would reduce, right? Because they're even. Do they reduce it in the book? That's how they leave their answer. So do you want to reduce it?
Nope.
Why not?
That's a lot of work. It's more work that you have to do. And you can mess up.
Yes, that is exactly right. You could mess up, and it's not even required. So check and see. Like, put those two fractions in your thing, in your calculator. And what do you get?
One
1.003154354 54354. You plugged it in wrong then.
Oh, there was already a 4 calculator.
Do y'all see how that works? Yeah. So did we probably do it correctly?
Yep.
If your answer isn't exactly that number, you probably did something wrong. Although your calculator may round the very last decimal. So beware of that if it rounds, then that last decimal won't be correct. Any other questions? Okay, let's look at one more. 13.012 repeating is a rational number. They say it is. We're going to prove that it is. What is the very first step? Number as a decimal. Do you agree? Dot 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 means etc. Okay? Now what am I going to do? Why by 10? Only 2. One number is repeating. So 10 in. Where's my decimal place going to be? Behind the 0. So 130 point what? 1, 2, 2, 2, 2, 2. Right? Have a bunch of 2's. It's a lot easier if you have your decimals lined up and if you have all your numbers lined up. What is the next step? Okay, so do these cancel out right here? We get a 1 there, but do these cancel out? And these cancel? All of those cancel. Does that make sense? So we have 1 and then what number? 1.7 117.11. Now what? Divide by 9. What do I need to multiply by? So I need to add 2 zeros to the denominator. What do I need to do to the numerator? 2 places. Check and make sure that that works. They wrote mine as a decimal.
13.012222.
So did we probably do it correctly? Any questions here? Did you see how these work? Are these great because you can check your work? You can check your answer like immediately. Plug it in. If you don't get that, you did something wrong. Does that make sense? Any questions?